what I'm doing right now is I already did an extraction on a very, very complex, and I didn't wait long enough, which is what I was afraid of. So, you can definitely tell we're doing it live here to make Bill O'Reilly proud. So we're going to bring it all down. I'll have to talk a little slower. This is not meant for a 90-second demo. This is meant to be permanent infrastructure. So there is kind of a warm-up period that I'm crossing my fingers and hoping that I kind of like am giving it enough time for some of this stuff. It's mostly a catchy pulsar that needs a little bit of a warm-up period. It needs to stabilize. So let's see, everything is up. So I'm going to give you a little bit of time to talk. So what I did is I took a recent astrophysics paper off of Archive. I think I titled it Pride of Satellites. It's an incredibly complex paper about stuff I have no idea about. And we did a full extraction on it. And what I'm going to do is I'm going to load that extraction in here. Now, we've actually done a lot of tests using Cohere's Aya 8B, actually, for our extraction process. And it's been one of the leading performers of models in that range, actually. So if anybody's looking for models in that 7B to 90 magic sweet spot, you really should look at Aya. I will say, though, and this is a really interesting topic that I'd love to talk about later, we've tested both the Cohere API for Aya 8B and an Olama deployment of Aya 8B and got very different results. So we found that very, very interesting and don't really have an answer for that right now, why that happened. Okay, so I gave it long enough, it's stabilized. So what I just did is, again, this is GraphRAG. I've already built a knowledge graph. What I did is we have knowledge graph triples, and I'm now loading them into queues, and these are being pushed back into the system. And, oh, I didn't wait long enough. See, give me information. Let me now load in the vector embeddings. Save these and type in, if I can find it, or I can probably type it up now. So this is actually loading RDF triples along with mapped vector embeddings, restoring the RDF triples in Cassandra, using Milvus for the vector embeddings. Let's see what we've done. We are done. So let me make sure that we loaded all of them. This is just a script that's going to show us how many graph edges have been loaded. And that's all of them. This particular extraction for this 20-page document had actually extracted 3,311 RDF triples for it, which is a really, really, really high number. Now I'm going to run, and again, I can change all this stuff and show it to you later, but just kind of zipping through all this for time. This is actually running a RAG query based on that graph, which is asking the simple question, give me 20 key points from this paper about Leo 6. And I think I actually said, give me 20 key points about how they actually, the researchers led to the discovery of Leo 6. And again, this is going to take a little bit of time. We're also waiting on Cohere's API to respond. We're waiting for all RAG algorithms to actually go in, pull a subgraph based on the query, based on the vector embeddings. That's all getting pushed back into the RAG context, which, again, if you were optimizing for latency, we might choose a smaller subgraph for that. And this is 20 key points about the incredibly complex astrophysics topic about the discovery of Leo 6. And again, this is from a paper that was released last week, so no model is going to have knowledge of this. This is based purely on a totally naive extraction. I did not see the extraction with any information about what it was extracting. And as you probably can imagine, if you do see the extraction, you get better results. All this can be optimized. But again, all of this is released under TrustGraph, which is a totally open source project. Any questions?